One second. All right. Go ahead, Dave.
All right, so my demo today, I'm going to be talking about hashcat and a little about how hashcat works, right? So here we've got a hashcat that is completed, but what I wanted to talk about was how do you actually set this up, right? So how do you know what you need to put in for your hashcat, right? So I'm going to go ahead and clear my screen, and I'm going to run an ls, and I'm going to less this hashes.txt. Right. So here I have a bunch of hashes that I've put that are MD5 hashes that I've gone ahead and put in this text file. And I'm going to go ahead and open a website so that we can kind of get a general idea here, right? Because if we get the first hash right, then we know that we've set it up properly. Let's hope that this website loads. Okay. So I'll go to a website called Crack Station.
I'm a fan.
Right. So yeah, so this is just like online password hash cracking. If you go through some security classes, like at a community college or even at your university level, you may be familiar with this, where supposedly, you know, this is going to crack through LM hashes, so land manager hashes, NT, LM, land manager hashes, all the MD hashes, and then some SHA hashes, and then RIPE, and then whirlpool hashes. So we're just doing this just to get a quick idea of what that hash might be. And then it says it's unknown. Okay, so why is it unknown? Well, maybe it's part of my part of the way that I copied it in. Maybe there just hasn't been hashes that have been found in here before. But that's okay, because we have hashcat. So general idea here is that if you're playing games like Hack the Box, or doing you know, even some pen testing, or you know, even just system administration, and you find passwords on systems, they are not going to be stored normally in clear text, right? A lot of more advanced systems and configurations will hash their passwords, right? And that's a mathematical function that creates a it's supposed to be a non-reversible function, right? So I put my password in to a math function, and it runs through, and it's supposed to put out these hashes here, right? And the tool that I used there is called less. Less is a easy to use tool. It allows you to go up and down in a looking at a file in a read-only mode. Okay, so let's look here. So I've got this command here for hashcat, and I'm going to go ahead and copy that to my line because I've run this before, so that we can kind of take a look at it. And I'm not going to run it just yet because there's some things that we need to talk about first before we start running the hash. We start running hashcat, right? So first, hashcat, you have to tell hashcat what you're looking at, right? So we have the A flag, and we have this M flag, and then we specify where our hashes are. And then we need to specify a word list, so a dictionary file that we want hashcat to go against. And then you need to give hashcat rules. So all of these things are included in Kali Linux. If you haven't already and you have a Kali Linux distribution, one of the really nice things about it is this USR share directory. It has a lot of really useful tools, right? Like, so this word list directory has this rocku.txt. It'll be a tar gz file, and this gets updated every time you update your Kali system. And this essentially has, like, you know, the top commonly used passwords that have shown up in dumps. And then there'll be word lists for other things. And then hashcat rules specify There's several different hashcat rules that are out there. This is one that is specific for the types of hashes that we're going up against. And in this case, we're going up against, I believe, MD5, right? So let's kind of look at that, right? So we'll man hashcat to get some more information here, right? So M specifies hash type, right? And so hash type will be followed by a number. A refers to the attack mode, so how we want hashcat to behave. And then there's a bunch of other functions that you can put in here. Like you might have seen that I had the a force in there, so that's forcing hashcat to run. O, which you can use to define an output file. There's big O, which we'll talk about in a second here. And this isn't like big O notation in terms of like algorithm complexity. This is a flag that you need to use because the type of kernel that we have on our machine isn't specific for the system that we have, right? So here we go, right? So here, this is talking about, and then there's some other things, right? Because hashcat, normally what you would do is you would have hashcat on a server, and then you would use this brain flags to connect to the hashcat server that would have like GPUs and other things like that, right? So attack mode options, right? You saw that I put an attack mode option in there. So that's saying that I need you to try the hash in this particular way, right? So first off, we're saying 0, right? So we're saying just do a straight comparison, right? You can think of this as kind of like a brute force, but this is more just like take the rules that I give you, hashcat, and take the list that I'm giving you, and I want you to try to do a comparison. So hashcat will run through the rules. It'll try to reverse the hash. It'll then compare the output that's coming out of the hash and the pattern to what you put in the dictionary file, right? And so in this case, the type that we gave it was 100, right? Because we're using SHA-1. It'll take more time based on the different hashes that you have and the complexity of your system, right? So let's kind of go over to this other tab where I've already run the hash, and we can kind of talk about the command that I put here, right? So it took me a while to sort of figure it out, but so I said hashcat. I want you to use the straight attack mode. I want you to go against SHA-1. Here are your hashes. Here's the word list that I want you to try. Here's the rule set that I want you to try. And there are several different rule sets. Some of them, you can think of them almost in the same kind of way as like rainbow tables and things like that. But that's almost a whole other talk. But basic idea is when you're trying to reverse hashes, you need to figure out what rule set that you need to use to begin with. I use this rule set quite often. I think for me, I say to myself, that's the default rule set. But I know that it's not. So then there's this O. And so this O flag, you actually do need to run whenever you're in your Kali VM, because hashcat underneath the hood is running this OpenCL API. And that OpenCL API doesn't play super nice when it's inside of a VM. Hashcat really wants to be on a physical system, but it can do the work inside of here. So let's kind of look down here, right? So what ended up happening, right? So I said, go straight. So it's going to use the dictionary cache. And so it's going to build that from the word list. And so once it's built that word list, it's going to say, these are how many passwords are in the word list. And then it's going to tell me how long the runtime is. And so these different hashes ended up taking about 4 seconds to compute. And here they are, right? So I've got password, and then password exclamation point, password 123, summer 2019, and summer 2020. So as hashcat is running, It'll keep running most of the time until you tell it to close. Right. So right now it's got these 83 digests. You can see in the guess mode. That's kind of what I say is like the status. So it's 100% done, but it's still chugging through that list, right? So it's going to take a significant amount of time to get through our list, but that's kind of the general idea here of hashcat, right? You give it some hashes, you figure out what mode that you want to do it in, you tell it what type of attack mode that you need it to do, and then you give it a word list. If you're doing like a straight attack or a dictionary attack to compare the recovered hashes against with the clear text passwords recovered. And then you give it some rules that specify how you want hashcat to behave. And so those things will be loaded in, and that's kind of the general idea, right? Like, and this is actually a hashcat is I would consider hashcat at times like a system administration tool, because you should check to see, or just like a developer tool, like you should check to see, is the hashing that you're using, like, is it sufficient enough to take a long period of time, right? So let's kind of go back and we'll look at some of these files that I have in here, as long as I'm typing. So we'll do a less of this try and hack me list. And so we've got one hash in here. And let's go ahead and copy that, and we'll put it over here in our crack station. And I'll say I'm not a robot. And we'll say crack the hash. Right. So it says that this is MD5, right? So this is going to take significantly less time for us to try to crack than it would if we were just using those NTLM hashes, right? So sorry, those SHA-1 hashes, right? And you can see here in my history, right? I've tried it several different times, right? I did a mode where I was trying against an NTLM hash. This took several days for this to actually complete. SHA-1, it'll take about an hour for it to completely go through all of the results. And that's the general estimate, right? I actually started this about 2 hours before this meeting, and it's still chugging through that list, right? So let's kind of walk through this here, right? So we want to crack this try and crack me, right? This try and hack me one that we have. So you can run hashcat without sudo, but I've just had better success if I just use hashcat with sudo privileges. So we'll go straight attack mode, and we don't remember what mode we need for MD5, right? Because that's what crack station told us. So yes, we could Google it on the internet, but let's be good system admins and let's use the tools that are here. So we'll go hashcat, and then we'll go page down, page down. So in man pages, if you want to quickly fly through the pages, just kind of go with page up or page down, right? So we see that it's 0 for MD5. So we'll go ahead and try that. And then here's some other things to quickly note. If you run into salts, there are other hash types that you would need to use and other ways that you would need to try to crack those hashes. A salt, and I'm sure someone can correct me if I'm wrong, best I understand is salt is just you can think of it as like a secret that we put into the hash algorithm as it's going through to hash things. And the salt is usually only known on the system. But if you can figure out what it was salted with, you can try to recover the password. Right. So let's go back, and now armed with our new knowledge, we'll go M0, and then we'll say that try and hack me, and we'll just copy this line that's above, copy our selection, and we'll do paste, and we'll say big O at the end of the line. Oh, goodness gracious. Okay. So we'll say big O over here. And important thing to remember, don't try to put spaces whenever you're using option flags. It's not a good idea. And we'll give it our sudo password here. All right. So yeah, so I did kind of want this to happen, right? So if you're trying to crack hashes already on your system, hashcat will not let you do that. Even with you have that force warning, because it can interfere with the hashcat that's currently running. So best thing to do is we can just hit a pause on our current running hashcat session, and we can try to kick this one off again. Make sure that I put the right flag. And again, right, so even with pausing hashcat, it's not going to work, right? So it's kind enough to tell us the PID number, so we'll copy that into our keyboard. And this is one of those things that when I was first playing around with hashcat over the weekend and before, I kind of had to get used to. And this is kind of why they say, hey, if you're going to run hashcat, you probably are going to want to get a dedicated password cracking box, because it can just cause a lot of problems. All right, so we've gone ahead and killed our hashcat session. And so now it's running, and it's going to go through and try to find what that hash is, right? And so what we want to know is it going to give us the same result that CrackStation gave us, right? So CrackStation says that the result is the value easy. So hashcat should inevitably give us the kind of the same result. And this may take a little while because my system is very underpowered. And so we'll just kind of let it do its thing. All right. So it's gone through and it's tried to crack it, and we can see right here, right? So easy is that value, right? So hashcat found it successfully. And what's important here is to pay attention to that. But when you're trying to crack through these things, hashcat will also tell you candidates, and it will also tell you whether or not it may or may not have been using salt for the password, right? So one of the candidates that it says is if football 1VN and CECCEE. Why does it do that? Well, because it can depend on the hash type. MD5 is known to have hash collisions, which has been talked about in a previous episode. So that might be a possibility. Another possibility is that, we may, easy may not be the true value, but this is hashcat's best guess, right? Now, if we were actually running a hashcat server, we might get more accurate results being pushed back, but I do not have the money or resources to run a hashcat server. Okay, so that's about it for my hashcat tutorial. Are there any questions?
Yeah, so I was really happy you showed this, because I really have wanted to use hashcat, but I thought you needed to have an NVIDIA video card, and I didn't have that. So in a lot of these cases, I didn't get to run hashcats because I don't have OpenCL and NVIDIA. But you showed us how to do it within a VM, so I'm so happy because yeah, in the past I've been stuck with John the Ripper, right? Because but I know all of the people who do this professionally, the cracking, they use hashcat. So I'm really happy to know that you could run this in a VM. That was really good. One thing that I did wanted to share though was the information about the salts. So there is history there, right? So you sort of have it. You have the explanation, right? But the reason why they introduced the salt historically was originally we had this problem with rainbow tables. What rainbow tables are is that someone went and hashed out all of the passwords in wordless, right? So you have this big database of all of the hash values with all of these passwords, right? So people, if they use a password that was in this database, they could just look it up in the rainbow table, boom, then you have your password, you put in your hash. So to solve that problem, they introduced a salt. So now with that unique salt value, if the rainbow tables wanted to sort of keep on creating these rainbow tables, then they would have to generate all of these hashes for each of those salts, which is not going to be feasible in terms of processor and memory space. So that's why they introduced the salt, so you could defeat this tactic of already having pre-computed hashes of all the passwords. It has a rainbow table, then you just look it up. So to get around that, it's like, okay, now we're going to add something else to the computation that you would have to know. So if you think about it, the problem there is if you use a salt that there's already a rainbow table, then you're screwed, right? But so use something that's kind of unique to yourself. That's the whole idea behind the salt, and then you're good. So that's sort of a little quick spiel on salts.
Yeah. Great point, Candy. Thank you for the history lesson. Yeah, and so I too ran into that issue when I was first playing around with hashcat, where I was like, oh, it's not going to work on my system. It's not going to work in my VM.
Yeah.
Well, it does. It's just if you want to have the full firepower of hashcat, right, to have that quick turnaround, then you need to go get OpenCL approved soft hardware and the NVIDIA cards and all of that. So if you have a gaming laptop and you've got your Kali or something like that, you may be able to do a GPU pass through to your VM. I don't know. I sadly I have a very underpowered laptop that I run everything on. But maybe one day. But no, it's a pretty cool tool. One of the nice things about it that I'll have to someday play around with is this idea that you can actually kind of chain these different tools together, right? And I think that that's something that I've needed to kind of wrap my head around is that if somebody gives me hashes or I'm able to grab the hashes, okay, then I should be able to throw this into an output file, and then that output file gets picked up by Hydra, right? Or and so Hydra should then go out and start putting in that password to try to log into SSH. And then now that I've logged in to SSH, I should be catching the session and then immediately dropping some kind of tool. So going through this process of figuring out how hashcat worked was going online and reading the hashcat man page, but it's definitely got my mind whirring and spinning. So with that, do you have any other questions, Candy?
Nope, that was it. Good job.
Thank you.